Now this is about the ligaments of the vertebral column. So here in our vertebral column, total 6 ligaments will be there. Total 6 ligaments will be there. These 6 ligaments are going to cover the both intervertebral joints and facet joints facet joints along the full entire vertebral column. First ligament name anterior longitudinal ligament. Anterior longitudinal ligament. Second ligament posterior longitudinal ligament. Third ligament ligamentum flavum. Fourth ligament intertransverse ligament. Fifth ligament spinous ligament, and sixth ligament supraspinous ligament. So here I show one by one. See, this is body of the vertebra. This is body of the vertebra. This is IVD. So this is anterior longitudinal ligament, anterior to the body. This is posterior longitudinal ligament. Suppose if this is spinous process, this ligament is supraspinous ligament. The ligament between two spinous process is interspinous ligament. The ligament which we are seeing here, this is ligamentum flavum. One more ligament will be there, that is intertransverse ligament. I'll show this ligament when we are discussing that ligament. So now first we'll see anterior longitudinal ligament in detail. Now first ligament is anterior longitudinal ligament. This anterior longitudinal ligament runs along the anterior and lateral surfaces of the body of vertebra. Suppose if we take one, this is we are seeing laterally one vertebra. This anterior longitudinal ligament will cross over, see, anterior and lateral. So it is going to cover the both anterior and lateral surface. Anterior and lateral surface. See, up to here also lateral surface also. This anterior longitudinal is going to cover the both anterior and lateral surface of the vertebral column. From where means from sacrum to the C2, from sacrum to the C2 cervical vertebra. C2 vertebra name also called as axis. C2 cervical vertebra. From sacrum to the C2 cervical vertebra, it is going to it is from sacrum to the C2 cervical vertebra. The anterior longitudinal will be present. From C2 to occipital. So for example, this is C1. For example, this is C2 up to C7. Then thoracic region will be there. So up to C2, from sacrum up to C2, anterior longitudinal will be present. From here C1 is nothing but atlas. Okay, so here we will be having occipital bone will be there. So from C2 to occipital bone, the anterior longitudinal ligament is going to extend. Here this ligament name is called, from C2 to occipital bone. This ligament is named as atlantoaxial ligament. Atlantoaxial ligament. Remember this, atlantoaxial ligament. So next, the anterior longitudinal ligament will be having two fibers. First one superficial, and second one deep fibers. Superficial fibers, if we take, suppose if we divide anterior ligament into two parts, this is superficial. Superficial ligament means superficial fibers of the anterior longitudinal ligament is going to cover the entire vertebral column. Is going to create this deep. See, this deep layers. So deep layers of the deep fibers of the anterior longitudinal ligament. Deep fibers of the anterior longitudinal ligament is going to bridge the several deep fibers of the anterior longitudinal ligament. Fibers are short. Run between the single pairs of the vertebra. Run between the single pairs of the vertebra. So these are about superior and deep. Superior fibers will be entire length of the vertebral column. Deep fibers will between the two vertebrae, So it will be there, but the fibers will be short. Here, but longitudinal, the superior fibers will be long, but deep fibers will be short. It will be like this. In these deep fibers, but longitudinal ligament superior fibers will be like this one. And one more point, these deep fibers are going to attach to the annulus fibrosus. Deep fibers are going to attach to the annulus fibrosus of the IUDs, intervertebral disc. Deep fibers are going to attach to the annulus fibrosus of the intervertebral disc, and at the same time, deep fibers are going to provide stability to the intervertebral disc. Okay. And one more point, the development. So here the anterior longitudinal ligament is well developed in lordotic curvatures compared to the kyphotic curvatures. What it means, the structure of the anterior longitudinal ligament will be well developed in the lordotic curvature. That means in cervical and lumbar regions, the anterior longitudinal ligament is well developed compared to the kyphotic. Kyphotic means thoracic and sacral regions. Compared to these two regions, thoracic and sacral regions, cervical and lumbar regions, this anterior longitudinal ligament structure is well developed. And one more point, thickness of the anterior longitudinal ligament. The thickness of the anterior longitudinal ligament will be increased from the T12 to S1. So that means If you take one vertebral column, so this is cervical, this is thoracic, lumbar and sacral. From lower thoracic region to the sacral region, lower thoracic to the sacral region, the thickness of the anterior longitudinal ligament is more. Thickness of the anterior longitudinal ligament is more. Why? Because here vertebral body also size is big. Vertebral body size also big, so that's why anterior longitudinal thickness also will be more. Next point here, tensile stress. Tensile stress. Tensile stress, we don't know what is tensile stress means. If we take one object, if you give distraction forces, how much the object can deform. That is tensile stress. The tensile stress of the anterior longitudinal ligament is more at the cervical and lumbar regions compared to thoracic and sacral regions so that in cervical and lumbar regions the anterior longitudinal ligament can stretch more compared to thoracic and sacral regions. Next point, compression. Next point, compression. Here we saw tensile stress. Now we'll see compression. Suppose here one vertebral column is there. This is anterior, this is posterior. Here one vertebral column is there. This is anterior, this is posterior. If this vertebral column is going for flexion, if it is going for flexion like this, and here this is flexion, okay, this is extension. If this vertebral column is going for extension, if this is going for extension, so when vertebral column is going for flexion, anterior longitudinal ligament will be compressed. Ligament. Okay. If it is going for if vertebral column is going for extension movement, that time anterior longitudinal ligament will be stretched. Okay. This is one point. Next point, neutral position. When the body is in neutral, suppose one vertebral column is there here, here it is not in flexion, not in extension, that means neutral. So when the vertebral column is in neutral position, anterior longitudinal ligament will be loose. So it is not tight, it is not stretch also. Okay. Last point, anterior longitudinal ligament is two times stronger than the posterior longitudinal ligament. See here we are having posterior transverse ligament. So this anterior longitudinal ligament is two times stronger than the posterior longitudinal ligament. So this is about anterior longitudinal ligament. Okay.